So in this brief video, I just want to introduce a term that we're going to use quite a bit, and it's the idea. It's called critical values, a critical value of a function. So typically it's defined to be any x value in the domain where the derivative is equal to 0 or the derivative is undefined. Now, we've been finding these all along when we're checking for where the first where a function is increasing or decreasing. We looked at second derivatives and tried to find these where the second derivative was 0 or undefined. So we typically will call those critical values. All right, so what are they actually referring to? We have an example here of a function. So where the derivative is equal to 0 are the horizontal tangents. So I have right here a horizontal tangent. My derivative is changing from increasing to decreasing. So this point right here would be called a critical value. And right here, we're changing from decreasing to increasing. And my derivative, I have a horizontal tangent there as well. So my first derivative is 0. And so the critical values are at those 2 points. And if I zoom in a little bit, that looks like it's actually just to the left of the y-axis. So I'm just going to call that -1. So that's one of my critical values. And the other one is located here, which looks like it's just above 2. So I'll call it 2. All right, so those are the 2 critical values for that function. Critical values are also where your first derivative is undefined. So we can see that the first derivative, if this is my function and I was to take a derivative at this point here, well, that would not be defined, right? We can't take a derivative at a cusp. So that's located at x equals 1. So x equals 1 is a critical value. And then in this last picture, I have a cube root function, and it has a vertical tangent at the origin. And so the first derivative would not be defined there. And so it has a critical value at x equals 0. Now, it is possible to have functions that have no critical values. And so what do I mean by that? Well, let's take a look. Let's throw out this function, y equals e to the x. And if I take the first derivative, y prime is e to the x, right? Well, a critical value is where this is equal to 0. E to the x equals 0. Where does that happen? Well, that is not possible. Remember that y equals 0 is actually a horizontal asymptote for this function, and e to the x never reaches it. So e to the x will never equal 0. So that's not possible. Where is e to the x undefined? Well, that's not possible either, because this is defined for all real numbers. And so it has no undefined value, so that's not possible. Therefore, it has no critical values. All right, so just wanted to throw out several cases of examples involving critical values. We'll be using those to determine extrema of function in our next lesson.